Hello, lovely people. I'm hoping you're having a lovely day. We're going to be starting a web class on strong acids and bases really soon. I'm just going to wait for a few more people to show up. Say hello if you are around. Hello, Bass. Hello, Logan. Nice to see you again. Does anybody want to tell me about how their week is going, how their studies are going while we wait for some more people to show up? My lovely colleague has just put the presentation that you can download in the comments, so feel free to open that, fill it in as you go, print it off, however you want to do it. Oh, Bass is stressed out. BMAT entrance. BMATs are a little bit scary. It's mainly GCSE knowledge though, so you should probably be okay as long as you've revised that. Hi, Samiha. I'm from East London too, so we've got two East Londoners here. Hey, Aisha. You might not have covered it yet, so it depends on how your teachers do it, but you'll cover it at some point. It's on all of the exam boards. Oh, Samiha, I'm sorry you have a chemistry mock. Remember that mocks aren't the most important thing. They give you an idea of how you should be revising or what you need to revise. So it's mainly for you, I would say, unless it's going to be giving you predicted grades for university applications, but you should have already applied, right? Oh no, maybe not yet. We shall see, but I hope it's fine. Yes, BMATs are scary. They are super scary. We've got so many medical people here. Hello, Buzzkill. That's an interesting YouTube name you have there. Okay, I'm going to get started because it is 6:31 and I think that probably means we can start. Right, okay. So I will share the presentation with you. You're welcome. I was always rubbish at like accepting pep talks when I was doing my A-level, so I never know how much they actually help. But I hope it was like a bit. What is my preferred board for chemistry? It depends on whether you're talking about to teach or to learn, because I think edXL has like the coolest chemistry in it. But I think OCR can be like a little bit more minimal, so it's less to revise, but I think edXL has the coolest stuff, which, you know, as a chemist is the bit I enjoy the most. This is the fourth web class, the fourth year 13 web class. You missed two, there were two rate equation type ones, and then one equilibrium one, and now this is strong acids and bases. Okay. Yeah, so our OCR, the Salters course is quite different, the way that it's run. It's like a nice course, but it's, yeah, it can be a bit tricky. Yes, they are, Reese. You can look at the previous live streams on the SnapRevise YouTube page. Just scroll down when you're on the SnapRevise homepage. I'm gonna start because I keep, oh, right, I'm introducing myself. Hello. So you guys may already know me because lots of you have been for the previous ones, but my name is Georgia. Hi. Head of chemistry at SnapRevise, this internet land studying place. I did a kind of master's degree in chemistry. It was like split between chemistry and a bit of neuroscience, so I have some biology in there too. And I've been teaching and tutoring for the last 6 years. And I keep in mind that every time I say that, the time sort of like adds on. So maybe I should have like a running count for days, but that might be a bit much. But yes, for quite a while. Where do I teach? I teach here in internet land now. This is my job now. So internet land is where I teach. Cool, web classes. If you haven't been here before, just keep in mind that they are key points and a recap. They are not every single detail that you need to know. You need to be like taking charge of your own sort of list of details from your spec points, which I'll get to. We also will be looking at exam technique and answering exam questions. And then at the end, you can ask me some questions. And this is sort of like the last week of the free web classes before SnapRevise 2.0 launches on October the 16th. which is really exciting. And then we have another week of free YouTube ones, and then most of them are going to be moving on to our website. So this is our taster for you guys, and just to sort of like see how it runs. I hope you've been enjoying them. Internetland is the best, Buzzkill. It's going to be weird calling you Buzzkill. It sounds so negative. Yes, so I'll tell you more about that at the end though, because we should get on with actual work. As usual, there's a giveaway. So if you follow us on Insta, tag us in your story with a screenshot of the web class, then you may win a free account, which is nice. And then everybody gets a coupon code, which makes subscribing cheap. So stay to the end. If the learning is boring, then at least you can stay to the end for the coupon, which is sad. I hope that the learning is not boring. I'll try to make it as interesting as possible. Sanjita says, I have the same question on this first web class on acid base. Yes, I don't know what you mean by that. Can you reword that, Sanjita? And Javier, I'm getting to exam boards. So objectives first. So what we're going to be doing is acids and bases in terms of proton donors and proton acceptors. So that's your Bronsted acid and base definitions. We're going to be doing how to calculate the pH of strong acids, and we're going to be doing the ionic product of water. We're not covering the differences between monobasic, tribasic, and dibasic acids. Today, we're not covering buffers or weak acids. We'll do that another time. There's just too much content to do it all at once. Raquel, obviously, or Raquel, one of those. Tell me how to pronounce it if I'm doing it wrong. SnapRevise is obviously what I'm going to say, because I, make content and teach classes, and I do my best to make them as lovely and helpful as possible. So I would not recommend anything else. Javier, we're doing AQA, OCR, and Edexcel. OCR-B is not, so it doesn't have technically like different content on this topic. It just does it in a different order from OCR-A. So I wouldn't worry about too much for this topic. If it ever sort of isn't in there, I always mention it. So like I'm leaving this on the AQA spec page, and I'll let you guys sort of glance through the spec points for whatever your exam board is. Have a look. I won't stay on there for ages. I'm not going to read it out. Sarah, yeah, I'm really sorry. It is a bit of a weird syllabus. The resources aren't actually that different from OCR-A, apart from the way the exam is run. It's just done in like, they try to do it in context. So like all of the things you learn in OCR-A, but like in context of the real world. So technically you're learning the same things. There's just sort of like extra contextual details. So the OCR-A resources you find online should be useful as well. Here are OCR spec points. And also Sarah, am I Sarah or Sarah? I'm gonna tell me which one. If you look at your OCR-B specific specification points and compare them with the OCR-A ones, you'll be able to see which ones are the same and which ones are different. And so if you end up using OCR-A resources, you'll know what extra things you need to take a look at. So do have a look at your spec points. And here's the Edexcel ones. So somebody said, F, F, your name is not very descriptive. F says that notification says that this web class is about buffers. So essentially, because these are our first web classes, when we made the first 4 sort of presentations and we planned them out, we didn't know how long they were going to take. So we've had to change them a little bit since we started. So I've cut out a bunch of stuff because nobody wants to be sitting here for like 2 hours and a half, right? But we will get onto buffers, and I'm sorry about the confusion. Okay, let's take a look at the things that we need to know before we start, stuff that you should know from year 12 and from GCSE. Cool, yes, Sarah, that is what I will call you then. All right, so the pH scale. This one's nice and simple. You probably did this like in year 9 as well. What is the pH scale? What does it tell us? What do the different numbers tell us? Someone drop me a line in the comments about what is the pH scale? And I will drink my tea and relax while you do so. Ooh, Buzzkill has like the proper definition. I'm going for like the one you learned sort of AS or year 12/GCSE. Yep, Aisha says 1 to 14, 1 being a strong acid. Yep. Please put buffers free to view. I am not in control of that kind of scheduling, Jazel. I will mention that there is interest in that one being a free class, but I don't get to control it, I'm afraid. And then we have the biological hazard. That's a great name. Concentration at H. Again, you guys are doing the cool definitions, the one from year 13. I'm just going for like, what do we already know before we learned the year 13 stuff? Anusha says 1 to 14, alkaline, higher is alkaline, lower is acid, 7 is neutral. Yeah, that's what I was going for. So like we will get onto the way you calculate pH, but for now I'm just going for what is the scale. So the scale, whoops, goes from 1, and I'm going to put a 7 in the middle so I can label it. So this is sort of most alkaline. This is most acidic. And at 7 in the middle, we have a neutral, anything that's neutral. So these are just our basics. So can someone tell me so when you're in like year 7, 8, and 9, you hear acid and alkali, and then you hit A-level and university, and you don't really talk about alkalis anymore. You talk about bases and basic compounds. Can someone tell me what the difference is? What's the difference between the two? Why do we perhaps only learn about alkalis at the beginning and then swap to bases? Why does that happen? Yes, Jazel is also right about that definition. We'll be getting onto a more detailed definition in a bit. Anyone for the difference between alkalis and bases? Solubility, yes. Yeah, kind of, Buzzkill. Go in a little bit more detail for me. Yay, Fatima, hello. Welcome, you haven't missed much. Yes, thank you, Hader. Yes, thank you, Samaya. Yeah, perfect. So Hader says alkalis are soluble bases. So they are soluble, and the kind of proper definition is that they are bases, they are aqueous bases. So an alkali is an aqueous base, and a base has a high conc of OH/proton acceptors, and we'll get onto the proton acceptor thing in a bit. Yes, Anusha says all alkalis are bases, but not all bases are alkali. That is totally right. So base is the overall category, and alkalis are sort of like the soluble ones. And it makes sense that those would have been the first ones that you learn about, because a lot of the definitions of acids and bases depend on measuring the concentration of something in solution. So most of the time when you're talking about simple things, it makes sense to talk about the ones in solution. Yes, Sanjita, that is totally right. pH does describe how strong acids are. I'm going to ask about equilibrium constants. So you will have seen equilibrium constants in your equilibrium lecture, should we call it, lesson, web class, last week. What is an equilibrium constant? Hello, Sponge Cake. I'm just loving the names today, but you're going to make me hungry every time you comment. So that's a bit sad. So an acid is an insoluble base. No, acids can be soluble or insoluble, but you don't really get many. So acids are usually in solution. So we don't have like a non-in solution one and an in solution one. Yes, Aisha says, yeah, we're going to move on to the Lowry definitions, Jazel. So Aisha says Kc and Kp, Fatima says Kw. Yes, those are all examples of equilibrium constants, but what are they? What do they describe? Jazel says when the forward reaction equals the backward reaction, that is when something is at equilibrium. That's not what an equilibrium constant is, but it's a good start. All right, I'm gonna help you guys out. So equilibrium constants, basically they always describe the relationship between the concentration of the reactants and the concentration of the products when the reaction has reached equilibrium. So that's what an equilibrium constant is. So the reason why that's important for this lesson is because the position of the equilibrium between the products and the reactants is going to tell us about how acidic something is. So I'm going to write that down. So equilibrium constants describe the relationship between the concentration of reactants. Ooh, that does not say reactants. And products when the reaction is at equilibrium. And yes, Naim, could you tell me how to pronounce your name, Naim? It is a reversible reaction. It has to be a reversible reaction if it's at equilibrium, but that's kind of like under the definition of equilibrium rather than what an equilibrium constant is. But yes, it has to be in a reversible reaction, or there can't really be a difference between reactants and products. The rate can't be equal between the two because it would only be going in one direction. Yes, Hader. Yeah, perfect. Okay, so that's sort of like all the basics that we need to know to be able to do. Yes, it is. So the position of the equilibrium buzzkill is described numerically by the equilibrium constant. Yes, you are totally right, Fatima. It's not always concentration. We could be describing it with partial pressure instead. So perhaps I shouldn't have used the word concentration. It's sort of like the amount of. That is a good shout, Fatima. Thank you. Amount. However, we tend to be measuring the amount. Cool. All right. So the first thing we're going to do is learn the proper definitions of acids and bases rather than sort of the ones we usually work off of earlier on in the years, where we have sort of like wishy-washy pH-based definitions of acids and bases. So can someone tell me what the Bronsted-Lowry definition of acids and bases are? Anybody? I did see some sort of perhaps in there earlier, maybe. Yeah, thank you, Fatima. So acids are proton donors. Thank you, F. Acids are proton donors. And that is what you need to think of an acid from now on. So protons, remember, are the nucleus, part of the nucleus of an atom. And because hydrogen is only made up of one proton and one electron, when it's positively charged, i.e. it's lost an electron, it's just a proton. So when you hear proton, I want you to think H+ ion, because that's what it is. Yes, and Fatima and Anusha have said that all acids have a conjugate base, which is true. So what I'm going to do up here is put the equilibrium reaction between. So when I put A, I just mean acid, just a general acid. And that H there refers to the proton there. So that in all acidic solutions, we're going to be looking at an equilibrium between the acid and our positively charged hydrogen, so our proton. And in this thing here is our conjugate base. Because if it's negatively charged, it's going to be accepting something positively charged, like a proton. So this is the conjugate base. And if I put in an example like hydrochloric acid, something you guys should all be familiar with, conjugate, I don't know what the definition of the word conjugate is outside of chemistry. Sort of think of it as like the associated base. But if somebody wants to Google the definition of conjugate outside of chemistry, that might be helpful. Chuck it in the comments for me while I write this down. So cool. So this chlorine ion, the Cl minus, is the conjugate base of hydrochloric acid. And that's because anything negatively charged is going to be a proton acceptor. And as you guys have mentioned already, bases are proton acceptors. So thank you, Javier, for mentioning that. So bases are proton. And again, remember that a proton is the same as an H plus ion. So Buzzkill says complementary. So conjugate, is that the Google definition or is that your definition, Buzzkill? Complementary sounds about right though. So the complementary base. Cool. So, I mean, like, I think you guys can probably guess what the answer is going to be for all bases have a conjugate. What do they have a conjugate of? Is it always a negative ion? No. So things like, for example, water, which we'll get onto in a bit, the oxygen has lone pairs of electrons, which you should remember from last year. So lone pairs of electrons can form bonds with positively charged things as well, which would give water a positive charge. So it's not always negatively charged, but we'll look at examples like that in a bit. And yes, thank you. Acid from Harjir and Jazel. So yes, all bases have a conjugate acid. Coupled, connected, or related is what conjugate means as an adjective. Reese's definition is kind of like the one for language, which is probably not as relevant, but yes. So like, I think it just means sort of has a relationship with or like connected to. So, but yeah, I don't think I've heard conjugate used in any other context apart from verb conjugation, like Reese mentioned. Joining together, says Kate. Yeah, cool. So with our base, so like with acid, we use A as our sort of like general acid. We use B for our general base. So if you see an equilibrium reaction with HB, we mean sort of like A base. And, oh, sorry, that's the conjugate acid. So I'm going to put B minus plus H plus because it's a proton acceptor. And the conjugate acid in this case is what? Yes, Sundita. When the acid loses the H plus ion, when it donates it, it becomes its conjugate base. Because of course it could accept it again, which would make it a base. Somebody want to tell me what part of that equation is the conjugate acid? I don't understand what acid having a conjugate means. So like, I'm going to use Sanjita's explanation, actually. It's a pretty good one. So if you think of, if we say that an acid is a proton donator, so looking at hydrochloric acid, you've got a H plus, which is the proton, and you've got the Cl minus coming together. And that's what hydrochloric acid is. Once it's given away its H plus, it's only Cl minus. And Cl minus could accept a H plus, right? And the definition of a base is a proton acceptor. So if the Cl minus can accept a proton, it is now a base. But because it's related to the HCl, we call it the conjugate base. Does that make sense? What is aluminium oxide classed as? I don't know. I don't know. If somebody wants to send me a picture of what aluminium oxide is, I can take a stab. I don't know how many. I think aluminium oxide would be Al O3, and because aluminium's a weird one because sometimes it acts sort of ionic. So I would imagine that was sort of more basic than anything else, but not everything is an acid or a base. Yeah, I think there is a bit of a delay at the moment, Fatima. Perhaps just internet's being slow today. Can't be helped. Hopefully it won't interrupt things too much. But Aisha, is that making any more sense? And what I'm going to do while you guys answer me is I'm going to write down my example. Yes, something could be both an acid or a base, and that's when it's amphoteric, and we'll talk about that with water as well. So ammonia, this thing here is ammonia, and that is a good example of a base. It's a very common base used, and you've probably heard of it in cleaning products. And this is an example of a base that isn't negatively charged. So when that accepts a proton, it becomes an ammonium ion, and that ammonium ion is the conjugate acid. Amino acids are amphoteric. Yes, they are, because they're called amino acids because they have an acid group, which is a carboxylic acid. And they also have the amino group, which is a lot like ammonia, just like missing one of the hydrogens. So they can accept and donate electrons. And if you're doing biology, you'll have heard of zwitterions, which is essentially the fact that they kind of keep swapping their protons. Cool. All right. So it's making sense. Does everybody, so like, how much do I have left? Okay, we'll keep going, and then I'll get some feedback from you guys. So what we're going to be doing is looking at how you can sort of like identify which thing is the acid and which thing is the base in a given reaction. And those are, ammonia is a base, not an acid. The ammonium ion, so NH4+, is the conjugate acid, and that is a weak acid. But ammonia is a base. It's alkaline most of the time. Okay, so a lot of the time in your exam, you'll be getting acids that you recognize. So the most common acids are going to be hydrochloric acid, sulfuric acid, and nitric acid. So if you just sort of recognize them, you won't have any problem being able to identify which one is the acid. Anything with an H and a halide, almost definitely an acid. So you'll be all right as long as you remember that. Anything with, yes, HCl is a strong acid, that is correct. Anything with an OH, because OH minus is such a good base, is likely to be basic, right? So water is a bit weird. It's amphoteric, which means it's acid and a base. But most of the time, if you see an OH, especially if you see something from group 1 and an OH or group 2 and an OH, you've got a base. Yes, so Sanjita's right. So this isn't the last live. There's not going to be one next week, and then the week after there will be, and then most things will be moving to our website rather than YouTube. So in this case, here we have an acid, and here we have a base. So if hydrochloric acid is the acid, what is the conjugate base? So Sean says, what's the difference between H2SO3 and H2SO4? So sulfur is weird and can sort of like expand and contract its oxidation states. So you won't really see H2SO3 very much. It doesn't really matter, but H2SO4 is sort of the most common strong acid. NaCl, yes, thank you, Sanjita. So NaCl is our conjugate base. Because if you remember your sort of like ionic equations, if you were to split that in half, you would have an Na plus and a Cl minus, and that Cl minus is a good proton acceptor. How do you figure out if it's conjugate, Aisha says. So just 1 second and I will. So I'm going to just tell you that the water ends up being the conjugate acid. So essentially the word conjugate just means related, right? So because it just means related, you could essentially identify either as the conjugate depending on what's on the forward reaction. What the convention tends to be, if it's the strong acid, then that tends to be the acid. And if the base on the other side is weaker, then we call it the conjugate base. But if it's a strong base and the conjugate acid is weak, or the acid on the other side of the reaction is weak, then we call it the conjugate. So it tends to be the weaker one. It tends to be about what position the equilibrium is in, but you won't be asked to identify which one is the conjugate. It will just ask you to identify what's the acid and what's the base. It will be obvious in the exam question, I promise. Cl is the conjugate base, yes. Yeah, perfect. Okay. So as we were talking about, water is amphoteric. It's both an acid and a base because it can either accept a proton, like in its reaction with HCl, and become H3O plus with a Cl minus, or it can accept, it can accept a proton and be the base. So in this case, it's the base, or it can donate a proton and be the acid. So in this case, it's working as an acid. So here, what is the Cl minus? Is it a base? Is it an acid? What does the chlorine ion do? So what's the difference between the acid and the base? That's your Bronsted-Lowry definitions. Acids are proton donators. So anything that gives away a H plus ion is an acid. Anything that accepts a H plus ion is a base. So those, you have to like memorize those definitions. Can someone tell me? Yep. So Hajar says that Cl minus is the conjugate base. Yep, which is true because it can accept protons. And the ammonium ion, this thing here, is our conjugate acid because it could donate an electron. Acid plus base equals salt and water. Yes, Sean, that is true. Yeah, cool, perfect, Fatima. Okay, I'm gonna move on and ask you, is that making sense? Does it make sense? Do the definitions of acids and bases make sense? Does it make sense that a proton is the same as a H plus ion? Does it make sense? So Aisha, amphoteric means that something is both an acid and a base. It's the word ampho sort of like comes, like the word amphibian, where they can live on both land and sea. So it kind of means both. So both acid and base. And there's definitely a lag because you guys are sort of replying a lot later than when I'm saying things, but it's manageable. So we've got some happy faces here. So remember, if you're confused, you got to tell me what you're confused about so I can help. So is conjugate? So conjugate just means sort of like the associated acid or base. So you can't just say conjugate on its own. It's either the conjugate acid, so the associated acid, or the conjugate base. So I'm going to put like a list of acids here. So here we have HCl, we have H2SO4, we have HNO3, and their conjugate bases are the things that exist once they've already donated their proton, because remember that an acid is a proton donor, right? So the conjugate base of HCl is Cl minus because that's when it's lost its proton. When H2SO4 has lost, it loses 2 protons usually. So then it becomes SO4 minus, and that's its conjugate base. HNO3, once it loses its proton, it becomes its conjugate base, and then it's NO3 minus. So we've got so conjugate bases are just sort of like the base associated with a given acid. And base 2. So Judah. Why do acids or alkalis break things down? That's a really good question. It depends. This is more of a complex question than you would think. But when you donate protons to things, essentially that's often, not all the time, but for a lot of things, it makes them more reactive. So they're more likely to sort of react with themselves or react around them. So it looks around because they're sort of becoming other things. That's usually what we mean by breaking down, becoming. It just sort of, they make things more reactive. I hope that helps. It's kind of like one of those things where the only answer I can give you is so wishy-washy because you don't have the background knowledge yet. Yeah. Yes, thank you, Javier. That should be a 2- charge. Okay, so I'm going to do a list of bases and their conjugate acids as well, just to sort of clarify things a bit, because there seems to be a little bit a little bit of confusion, I think. So bases, which aggregates, what other bases can I? Common bases. So I think everybody's is glitching. So can you guys all refresh your page and see if that helps? Because I'm getting lots of people saying that there's some glitching going on. I'm not sure what I can do about it though. Could sort of lots of people refresh the page and then let me know if it's still lagging a lot. I'm glitching a lot. Okay. I am covering pH calculations, but it might not happen if you guys can't actually. Does that mean it's not? Yeah, it is glitching. So like I'm like watching it at the same time, but I never know if it's. That's good, Fatima. Refresh didn't work. Damn. Okay. Ooh, what can I do? The lag is, yeah, I can see it is really, really glitchy. This is tricky. Okay. Let me see if I can do anything with my internet. Refresh made the lag worse. Oh no. Okay. Calculations with partially neutralized. No, Daniel, not today. I won't be doing partially. Those are sort of like titration things. I'm not doing titrations today. Oh, unless it's in the exam questions. Oh dear, I'm not really sure what to do about the internet. I can disconnect and connect again, but I feel like that's going to make things worse. Okay. Stop and start again. I'm tempted to tether to my mobile data, but I don't know if that's going to make it worse. So I'm going to try it. And if it makes it worse, then I apologize, people, but I'm going to try that. Oh, it looks better now? How's it doing? Is everybody, is it working? Okay, it's working. I don't need to swap to my data. Okay. Okay. All right. It's fine. Okay, perfect. I will go back to the presentation. Right. Okay. And I have to think of some bases for you guys because there are not that many. So bases, remember, are proton. Oh, is it letting me draw? But it's not letting me edit things. Never mind. So bases are proton acceptors. So when ammonia accepts a proton, its conjugate acid is the ammonium ion, and it's an acid now because it has a proton that it could donate. Is that making sense? So like everybody that was sort of like number 2 and a bit confused about what a base was and what a conjugate acid was, is that making more sense? There's still quite a lot of a lag, but at least I'm not glitchy. There's a big lag. Yes. Anybody still confused? So let me know. Send me some yes, no. Ah, that's cute. No, Fatima, you just missed some glitchiness and the lag. Aisha says kind of. Ah, that's cute says yes. Yes is not helpful. Yes is not a. Tell me what is it. Okay, what we're going to do is we're going to do the exam questions, and then you're going to tell me if it's made more sense after the exam questions. So let's see if that makes things make more sense. Okay, so the exam question says, the following equilibrium occurs in a mixture of pure methanoic and ethanoic acids. Give the formula for the two Bronsted-Lowry acids in this equilibrium. So what are I'm just going to let you guys answer that. So if you remember that a Bronsted-Lowry acid is a proton donor, what are the two things in this equation that are acids? Sanjita, what do you mean by base 1 and base 2? I don't know what you mean by that question. Could you please clarify? Fatima, that's so harsh. No, I didn't find the lag cute. It'd be a weird thing to find cute. Okay, so Sanjita says HCO OH is an acid, which is that correct or not correct, do we think? Yes. And then we also have, yeah. Cool, perfect. Lots of people are getting that. So the next question says, write an equation showing the products of the equilibrium, which is set up when iodic acid is mixed with ethanoic acid. Yeah, so we're getting a lot of right answers for the first one. Anybody, any ideas for the second one? So what I want you guys to do, So this was a bit of a mean one because we haven't had a look at our data sheet yet. So what I'm going to do before we answer this question, and Aisha is right, this is tricky without your data sheets. So what I'm going to do, you will get a data sheet not with pHs but with pKa's, but we haven't covered pKa yet. So I'm going to give you the pH of iodic acid, and I'm going to make them up, because I only know the pKa's and pH is relative anyway, but I'm going to give you them so that you can answer the question. So iodic acid, I'm going to tell you has a pH of 5, and ethanoic acid, I'm going to tell you has a pH of 3. Please, lag is real. Do not say rude things or you will be removed. So if you want to delete that message, that would be good. Or my colleague will end up removing you. So please, no swearing, or even if it is sort of the patois version of swearing, delete, please. So we're not quite getting it right. What does a pH of 5 mean compared to a pH of 3? What would that, which one would be the stronger acid? Thank you, lag is real. Yeah, so Sanjita's is getting it. I don't understand how you worked out the first question. Okay, we'll go over that in a second. Yeah, so the pH of 3 is the most acidic. So which one is going to be acting as the acid in this case? I'll go over the first part in a second. Yeah. So Javier says that the ethanoic acid will be acting as the acid. Yes. So if ethanoic acid is acting as the acid, what is it going to be in the products? Anybody? Yeah, so Fatima's kind of already got it. But what is the ethanoic acid going to be when we're in the products? I don't know how much of a lag there is because I can't tell if you're answering wrong or if you're it's just really slow. What does the ethanoic acid become after it's donated? Yes, thank you, Harvey. I think it is the lag. Oh dear, this is tricky. All right, so once ethanoic acid has donated its proton, so remember that the H plus is the proton, it's going to be, oops, I've missed out a C. It's going to be CH3COO minus, which means that this, even though it's an acid, is acting as the base, right? So if it's acting as a base, it has to be accepting a proton. And if it accepts a proton, how many hydrogens is it going to have now? And what's its charge going to be? Yep. So Sanjita's gotten it right, but has missed out the charge. Can someone help me out with the charge? Yeah, there's going to be, so Samaya says 2. It's not going to have a 2 charge, but we do have, yeah, it's got a plus charge. Thank you, Buzzkill. Yeah, okay. It is, oh God, the lag is bad. The lag is bad. Yes, we have 1 positive charge. So what I'm going to do now is sort of run through, what do you do about the negative ion? So there is a negative ion. It's the conjugate base of ethanoic acid. So I'm going to quickly talk about the first question. So the question said, give the formula of the 2 Bronsted-Lowry acids. And if we remember, Bronsted-Lowry acids are proton donors. So what we're doing is we're looking for things that have donated H pluses. So we're lagging, can you guys tell me if we're lagging badly again? Oh, this is so tricky. I'm going to keep explaining and then let me know if it made sense at the end. So we're looking for things that have donated the H plus, right? So if we look at the HCOOH, on the other side, it's missing a H plus, which means that it must be a H plus donor. Yes? This ethanoic acid here gains an H plus, so it cannot be a Bronsted-Lowry acid. Over here, we have a CH3COOH2 plus, and this in that direction did donate a H plus, right? So it must be the acid. Does that make sense? I know we're getting some glitches, but could you understand what I was saying? It should be about an hour and 15 a quadri. If it keeps glitching, I'm going to try tethering to my data, but I don't know if that's going to be worse or not. I'm going to let you guys vote. Let's get some emoji feedback. Is it bad enough that I should try tethering to my data? Send me a smiley face or a sad face if you do not think it's bad enough for me to try tethering to my data. I can't even tell what you're replying to. Oh dear. Okay. All right. Buzzkill, that is not helpful. No, I have no lag. Okay, so Harvey has no lag. Oh no, we don't have any kind of... All right, so I'm not going to. Fatima says yes. Oh God, okay, I'm not going to. Again, glitch. No lag. Some people have a lag, some people don't have a lag. I mean, if my voice is fine and it's just my face, you don't really need to see my face. So that's fine. Yeah. Which face means which. The sad face is supposed to mean don't do it. Don't try and swap to your mobile data. The happy face is supposed to mean go for it. But if it's just my face, you really don't need to see my face. So I'm going to move on with the lesson. And then if my voice and the writing is a problem, then what we'll do is I'll try my mobile data, although that could be worse. I'm not sure. All right. So Jazel says my voice is breaking up. Oh dear. Okay. This is tricky. It's fine now. I'm gonna move on and hope for the best, people. So how is everybody feeling comfortable with conjugate acids and conjugate bases? Which bit don't you understand, Aisha? Which bit is confusing? So what we're looking at here is we're looking at the things you're looking in the equation, and remember that it can go forwards or backwards. You're looking at which chemicals have donated a proton, and if they have donated a proton, it means that they are acids. The first question is tricky. So you're essentially looking in the forward and backward reactions. If they lose a proton in either the forward or backward reaction, that means they're acids, right? Because they're proton donors. So this one did lose a proton because it went from having two to having one, which means that this is the proton donor. This went from having two to having one, which meant it lost a proton, which means that it donated one, which means that it's an acid. Does that now make sense? So if you look in the forward or backward reaction and it's lost a proton, it's an acid. Aisha, is that making sense? Which exam board is this question from? I'm not sure, a quandary. I do a mix of all of the exam boards that this is part of. I'm going to move forwards because we are running quite late because of all the lags. Yay, Aisha. Okay, I'm glad. All right. So we're going to look at how to calculate pH, which I know we've wanted to do. So pH is a logarithmic representation of the concentration of H+. And as I say sort of every time, if you don't know what a log is, you need to go over it in your own time. If you're not doing A-level maths, it makes things trickier. And I'm sorry about that, but I can't explain how logs work. You just need to know where they are in your calculator. So if you have a scientific calculator, which you should, it says log. So you press that button. So pH is what? Can someone tell me what the formula for pH is? And lots of you have told me, what that is already, but remind me, what is the formula for pH? And yes, Tharini, that's exactly it. Thank you, A quadri. So pH is minus log the concentration of H+. So if it's concentration, we do square brackets, and that should be in moles per dm cubed. So Sanjita says, I solved a question paper there and I got a question to find base 1 and 2 in a reaction like upper one. Okay, so what you might have to do is send in the exam question to SnapRevise. If you send it, I'm going to send you my email address, my SnapRevise one. And then if you send it to me, I will have a look, not today, but I'll make sure it becomes part of one of the web classes. And then what I'll do is email you when I'm going to cover exactly what you mean, because I don't know what you mean currently, Sajida. Do we need to know the formula, or do you get it in the exam? You need to know the formula. The formula is important, but it's not a hard one to remember. All you need to know is that you're doing the minus log of H plus. Cool. So if we've already sort of looked at the pH scale. So if you have a low pH, that means you have a high concentration of H plus, which makes sense because acids, as we know, are proton donors. And if you have a high pH, that means you have a low concentration of H plus, which makes sense because they are proton acceptors. So that's sort of nice and simple, and we're going to do a calculation. So you've sort of already, I'm going to add in our equilibrium arrows. So when we're looking at strong acids, so the reason that we're sort of specifically looking at strong acids today is because when an acid is really strong, so if it has like sort of like, if you're looking at like HCl or sulfuric acid or nitric acid, we kind of assume that all the time it's donated all of its protons because it's such a strong acid. So when we assume that, we can sort of think about H plus, so the concentration of the protons, being the same as the concentration of the acid you put in. So if it dissociates completely, the concentration of the protons is the same as the concentration of the acid, which means that it's kind of easy, right? Because if you know how much acid you put in, you can work out the pH. So I'm going to remind you guys of the formula for pH. So pH is equal to minus log of the concentration of H plus. And if we're assuming that it's a strong acid and therefore the concentration of H plus is the same as the concentration of hydrochloric acid, we're going to do minus the log of the concentration of HCl. So does somebody want to shove that in their calculator? You've been given a concentration of HCl, you've been given it in moles per cm cubed. So what are we going to need to do with that? Moles per cm cubed is not, it's not what we want, is it? We want per dm cubed. It's not a pH of 5. And that's because we have to be really careful about checking units. We need it to be decimeters cubed, not centimeters cubed. So what is 1.1 times 10 to the minus 5 in decimeters cubed? So remember that we don't divide by 1,000 if it's to the minus 3. We only divide by 1,000 if it's, so if we were going from centimeters cubed to decimeters cubed, then we do divide by 1,000. But because we're going from centimeters to the minus 3 to decimeters to the minus 3, we times by 1,000. How do you know which number to put in the brackets? So we're looking, so square brackets mean concentration. So it's the concentration of, and it has to be in moles per decimeter cubed. So we don't have a pH of 8. And that wouldn't make sense. So you can sort of check your own answer because it's hydrochloric acid. So there's no way it's going to have an alkaline pH, right? Yes. So Jaisal is correct. It does have a pH of 2. So if we times by 1,000, yeah, perfect, Fatima. Yes. So what we're going to be doing is minus the log of 0.01. You times because it's to the minus 3, Sarah. So if it's centimeters cubed to decimeters cubed, you do divide by 1,000. But if it's centimeters to the minus 3, to decimeters to the -3. So anything where it's per decimeter or per centimeter, you times by 1,000. Is that making sense? So the answer is 2. The pH is 2. Okay, does the conversion between centimeters and decimeters make sense to everyone? Cool, it's making sense. Okay, I'm going to go ahead and move on to the next one, which is essentially the same thing, but we're doing it backwards. So in this case, we've got sulfuric acid and water. And the solution of sulfuric acid has a pH of 1.5. So we're calculating the concentration of the solution rather than calculating the pH. So we're still using the same formula. It's pH to the minus log of H plus, and it's a strong acid because it's hydrochloric acid, which means that we assume that it dissociates completely, which means that we assume the concentration of the acid is the same as the concentration of the protons. So in this case, we know that it's 1.5. So it's 1.5 is equal to minus the log of H plus. And can somebody lovely tell me, how do we do the opposite of a log? What is the opposite of a log? And oh, look, we've already got, Fatima's said that it's 10 to the power of minus pH, which is correct. So the concentration of H plus ions is equal to 10 to the minus 1.5, which gives us what? And lovely, thank you, Sanjita. So I'm going to just do that to one significant figure for speed. So we have 0.03 moles per dm cubed. And because it's a strong acid, we assume that it dissociates completely. So the H plus concentration is the same as the sulfuric acid concentration. So we can say that the concentration of the sulfuric acid solution is 0.03 moles per dm cubed. It doesn't matter if my face is blurry. My face can be blurry as long as you can see the writing. Yes, Jaisal. To 3 significant figures, that's correct. Okay, wicked. All right. Last slide. Yay. Okay, so we're going to talk a little bit more about water. Yes, if you guys change your settings so that it's not HD anymore, that's probably going to help. Can I explain the first one again? Yes, I can. Possibly though, if I explain it again, we won't have time to do the ionic product of water, but that's fine. Okay, so the first one, so Sanjita, can you tell me, is it the conversion from cm cubed to dm cubed that you'd like explaining again, or is it the calculation itself? So Aisha, the inverse to log to the base of the natural logarithm, log to the base of the natural number is ln, log to the base of 10, which is this one. So you don't put in 10 if it's just 10, you just write log. That's 10 to the power of. So it does make sense that you would confuse those. Yeah, okay, so it's the cm cubed to dm cubed part. So what I'm going to do is so you will be familiar with the fact that if you want to convert from cm cubed to dm cubed, it's divided by 1,000, right? But if you remember from GCSE, when something's to the power of a minus, what we've really got is 1 over. We've got 1 over cm cubed to 1 over dm cubed, which means that whatever is the normal way of doing it, it's reversed. So if we were to divide by 1,000, it would not give us 1 over dm cubed. So we have to times by 1,000 instead. Does that make more sense when you think of it as a fraction rather than as a power? So we had 1 times 10 to the minus 5. And then if you times 1 times 10 to the minus 5 by 1,000, then you get, then you get 1 times 10 to the minus 2, which is the same as 0.01. Does that make sense? Thank you, Jaisal, for shoving that in the comments. Yay. Okay, cool. Let's move on to the ionic product of water. So, okay, so we've been talking about water, didn't understand the second question. So, Andina, is the reason, whoops, all right, almost spilt tea over the laptop. Is the reason you didn't understand the second question is the confusion of how you do the inverse. So are you doing maths A-level? Because there's something you're just going to have to sort of accept, that the inverse of log to the base 10 is 10 to the power of what's on the other side of the equals. I can't go into an explanation of why that is. You're going to have to sort of watch some maths videos to understand that. It's not part of chemistry. I really don't understand why they don't have like a maths part of the chemistry syllabus to catch people up, but they don't. Amdina, is that why it's confusing? I'm going to move forward. No, what's the confusing bit? So, all right, I'll run through it again really quick. Really quick, and then I'll move on. This is taking so. So, Dania, you do, if both protons are moved, we only moved one proton. As you can see, it's HSO4, not just SO4. Okay, so we're still going to be using, so pH is equal, again, so we know our normal formula, log to the minus log to the concentration of H plus. So we don't have the concentration of H plus, we're looking for it. We have the pH, which is 1.5. And we're looking for the concentration of H plus, right? So this bit, I think this is what most people will be confused about if you're not doing maths. So it's a bit like when you rearrange an equation, if you time something, if something's times on one side, it is it not just, yes. So if you time something on one side, usually in an equation, then if you want to move it to the other side, you have to divide it. The opposite of log, this thing, log to the base 10, is 10 to the power of. So if you want to move this log to the other side, you do 10 to the power of whatever on this side. So this is sort of maths knowledge rather than chemistry knowledge. So the concentration of H plus is 10 to the power of minus 1.5 because of the minus here, because the inverse of log. So what we're going to do is assume that because it's dissociated completely, the H plus concentration is the same as the H2SO4 concentration. And if you shove in 10 to the power of minus 1.5 in your calculator, you will get 0.03. And I have to move forwards, guys. So I'm really sorry. Where does the log go? The inverse of a log, so the opposite of a log is 10 to the power of, just like the opposite of a times is divide, or the opposite of a plus is a minus. It doesn't disappear. You're doing the inverse to get rid of it. But I really have to move forwards, and I'm sorry. But there's a question section at the end, and you can ask me more questions, but I have to sort of finish off so that the people that don't have questions can leave, and then the people that do have questions can ask me at the end. Okay, so we're going to look at the ionic product of water. And again, so we know that water is amphoteric, right? We've talked about that before, which means that it's both an acid and a base, which means that when you have, when you set up an equilibrium between its ions, you have water splitting into both its conjugate base and its conjugate acid. right? So this H3O plus is an acid because it could donate a proton and become water again. And this OH minus is a base because it could accept a proton and become water again. So the equilibrium is going to be, so remember equilibriums we always set up as the products divided by the reactants. So it's the concentration of H3O plus and the concentration of OH minus over the concentration of water. And if you guys remember your rules, if there's a 2 in front of there, you need to put it squared. Yeah, Jaisal, I completely agree. You need A-level maths to do chemistry. I don't know why it's not a requirement. I would do it differently if I was in control of the syllabus, but I am not. So you can think of it, Fatima, you can think of H3O plus as H plus, and we will get onto that in a second. So because water is in excess, and you can kind of assume that water is in excess in most reactions. What we mean by that is that there's so much water that the concentration of it doesn't make a difference, right? So essentially, when we're looking at the equilibrium of water between its acid state and its base state, we skip everything that has water in it. So instead of writing this H2O in there, and instead of writing H3O plus, we write H plus times the concentration of OH minus. So A quadri, lots of schools make maths a requirement for physics. Some don't. I think it's silly that they don't, but I'm not in control. Okay. So is that making sense so far, why we get rid of water in the equation? Does everybody understand what I mean by water in excess? Riley, Saoirse is right. We should be focusing. Please let me know if you understand what I mean by water in excess, because I know lots of people have problems with that concept. And I can't tell if it's a lag or if I'm just being ignored. How do you go from H3O plus to H plus? So they're used pretty interchangeably, Fatima. It's not so much that the water sort of like disappears from it. It's just that in chemistry, in any sort of aqueous solution where you have H plus, the H plus could either just be floating around, or it could be attached to the water as H3O plus. Protons are so interchangeable, and water is such a good acceptor and donator that it kind of, you can write H3O plus or you can write H plus. But for the ionic product for water, the standard way of writing it is H plus. So could I please repeat the bit about water in excess? Okay, so if you're having any reaction happen in water, and of course this one is in water, right? Because we're looking at water. There's so much water there that changing its concentration doesn't do anything to the equilibrium because there's so much of it. So if you're looking at our equilibrium constant Kc, all it's about is how much there is of something. So what I want you to sort of imagine is that maybe like, I'm going to write it down here. Maybe the concentration of H3O plus is like 3 moles per dm cubed, and the concentration of OH is like 6, and the concentration of water is like 10,000. There's just no point putting it in because it makes the other values so sort of, it blows them out of the water, no pun intended. So we don't include it because it's so big that it's pointless to include. Why does it have to be in excess? Why does it doesn't have to be in excess, it just usually is. It's usually in excess. Okay, so people, what I've left it blank here because I want you to remind you guys what is the constant, what is 298 Kelvin in Celsius? So that's usually room temperature. What is it? Kw is the ionic product of water, or the equilibrium position between acid and base of water. And A quadri, don't be like, that's like a little bit patronizing. So like, try not to do that. You didn't need to put the LOL at the end there. Try to be nice, please. Not 20 Ella, but 25. Yeah, 25 degrees is the room temperature we use in this. So if you remember that if you're converting between Kelvin and Celsius, you minus 273. Cool, perfect. Okay, so I'm going to do the question. So we're saying a solution of sodium hydroxide has a concentration of 0.5 moles per dm cubed at 298 Kelvin. And keep in mind that at room temperature, Kw, and you won't have to remember this, is 1 × 10 to the minus 14. So we want to calculate the pH of the solution. So we've been given Kw. We've been given Kw as 1 × 10 to the minus 14. And it's equal to the concentration of H plus and OH minus. We have, we need to rearrange this essentially, right? Because we've been given this concentration of OH minus because we can ignore the Na. And again, this is a lot like the strong acid rule. If it's a strong base, we assume that the OH concentration is the same as the concentration of NaOH. So if we rearrange the equation, we have H plus is equal to 1.0 × 10 to the minus 14 divided by 0.5, and we're in dm cubed, so we don't have to think about converting anything. And lots of people have already got it. So this gives us, so the concentration gives us 2 × 10 to the minus 14. Now, why does it have to be in excess? It doesn't have to be in excess. It just, water molecules, if anything is happening in water, the amount of water is just massive by default. It doesn't have to be in excess. It just is in excess. It's not like we make it in excess. It's just that we're looking at literally water splitting between its acid and base self, right? So that means that the whole thing is mainly water. There's only a little bit of H plus, there's only a little bit of OH minus. I hope that makes sense. Does that make sense, Tharini? And lots of people are right. So we've got the concentration of H plus now. So we need to use our pH formula, which is pH to the minus log of H plus. And you can just shove that in your calculator with the log button. So we have 13.7. So lovely, lovely. We've finished the actual sort of learning bit. Does that all make sense? Can we move on to our exam questions? Why is H plus the formula of the subject of the formula? So H plus is the subject of the formula because we have NaOH concentration, right? We've been given it, it's 0.5. So I shoved that in there. And to work out pH, you have to do minus log of H plus. So I rearranged this so I could figure out what H plus was, and we worked it out there. It's 2 × 10 to the minus 14. Does that make sense? So is everybody happy with that? Got lots of happy faces. I just want to make sure we're good to move on. Okay, I'm going to move on to the exam questions. Lovely, lovely. Okay, so a shampoo is buffered by the addition of a mixture of methanoic acid and sodium methanoate. The pH of this shampoo is 4.9. Calculate the hydrogen ion concentration of the shampoo. Okay, so we know our formula. Between 1 and 2. Okay, both Aisha and Tharani, hopefully the exam questions will help it make more sense. If it doesn't, you can ask me questions at the end. So we again have our pH is equal to minus log of H plus formula. Yeah. Okay, so we've been given the pH of 4.9. So I'm going to shove that in the equation. And if do you guys, so what is the, people, tell me, what is the inverse of a log? So remember, if it doesn't say anything at the bottom of the log, it's a log to the base 10. What's the inverse of a log? And Dan B, you are right that you sort of like jumped ahead a little bit. Ten to the power. Yes, thank you, Dan. So, oops. So we should have 10 to the power of, and we're doing a minus because there's a minus here. So it's 10 to the power of minus 4.9. So do not forget the minus. And so that will give us our concentration of H plus ions. And if you shove that into your calculator, you should get 1.26 times 10 to the minus 5. Cool. And I just as like a note, you can kind of check if you're right, because the power should be close to the pH. So the fact that it says to the minus 5 means that we should have the right answer there. I'm really glad, Aisha. I'm glad that you're getting it, because this is tricky. All the calculations are so hard on anybody that is not like really fluent with maths. It's not really fair. Okay, so we're going to calculate the pH of a 0.4 molar solution of NaOH. So this, if you see something like this, you want to be using your ionic product of water formula, which is Kw is equal to H plus OH minus. So what we're going to do is we've already been given the concentration of OH minus, because if you remember, I said we ignore the Na because it's a strong base. So we've got that by 0.4 because it's already in moles per dm cubed. And please check units every time, or you will, lose marks for no reason. Okay, so what we're going to do here is we know that the Kw of water at room temperature is 1 times 10 to the minus 14. So again, I'm going to shove that in, minus 14. I'm breaking up again. All right, I'm going to pause. The glitch is back. Why? The internet hates me today. It's fine now. Okay. All right. We have some serious issues with internet. Okay, cool. All right. So all I've done is rearrange. So I've replaced the Kw with 1 times 10 to the minus 14, because we know the Kw of water at room temperature is 1 times 10 to the minus 14. And then I've taken the 0.4 over to the other side, and that gives us the concentration of H plus. So when you shove that into your calculator, you should get 2.5 times 10 to the minus 14. And then if we shove that nicely into our pH formula, you should get 13.6, which is 3 significant figures. And I've seen you all sort of talking about A-level standards. So usually for the exam board, it's either 3 significant figures or 2 decimal places, unless stated otherwise. I sound like a robot. Oh no. Is it still glitchy? Do you have to know that it's mainly in the data sheet? Am I still breaking up? I mean, possibly the question section is just going to be really dodgy, because we're sort of done with all of our exam questions now. So I'm going to just sort of like run through the housekeeping, and if it's glitchy, it's glitchy. Because we're almost at the end, so there's no point in me trying to fix the Wi-Fi. I'll make sure it's fine for the next webcast, so not next week, but the week after. But hopefully, I don't know, hopefully it should be all right. So the things that we went through the definitions of acids and bases in terms of proton donation and acceptance. So that is the only definition of acids and bases that you should be using from now on. We learned to calculate the pH of strong acids. So keep in mind, you cannot calculate the pH of weak acids like this, because we have to assume for this definition that there's full dissociation of the protons from the acid. So that's the only time you can use this formula. You can't use it for weak acids. We'll come on to weak acids at some other point. And we learned to calculate the ionic product of water. Wicked. Okay, so this is all for SnapRevise 2.0, which arrives on October the 16th. So that's like, what, like 6 days away. So that's exciting. That's what these webcasts are for. So they're going to be part of the ultimate package. The idea is basically that you have like a tutor without it being the cost of a tutor, right? Because if you hire a tutor, it's like £30 an hour to like £50 an hour. And not everybody can afford that. In fact, most people can't. So this is definitely going to be cheaper than that. And the ultimate package will have web classes, they'll have drop-in sessions. So like basically I'll just be here and you can ask me random questions from your homework or from exam questions. And they'll be like, you can like send me messages and I will help you out with any questions. So yes, so if you already have SnapRevise, you'll be upgraded to the basic package. And then if you want to upgrade further to ultimate, you can. So again, if you use the discount code at the end of this, it's going to be a lot cheaper. And this is the last discount code that's coming out before the release. So you kind of need to do it. So here it is. Here is your discount code. Take it, have a look. It's SW40. And so you'll have immediate access to sort of like the current website, and then you'll be upgraded on October the 16th. Straight away. So I think I can't tell how much of a lag there is or if you're going to see this, but we're at the questions part. So if there are questions, please let me know. If you would like me to go over something. Can you get Ultimate for free? No, Dan. I wish it was possible to make things like this for free, but it isn't. It doesn't cost nothing to make these. So we have to get the money from somewhere, right? Everybody involved in making it has to eat, and all of the equipment has to happen. And it sucks that there aren't resources like this paid for by, you know, the government. But sorry, that's just the case. So the pricing has not been released yet. So that payment you just saw is like a one-off payment for access, like one-off payment for 2 years for access to the basic package. So that doesn't include the web classes and stuff, but it's the basic things. It is sad, Dan. It is sad. I'm sorry. But hopefully, like we did, like it's a lot cheaper than getting a tutor. So that's you can be the exception now. That wouldn't be fair, would it, Dan? That wouldn't be fair at all. Yes, you do buy it separately for each subject. Okay, so I'm going to give it another like little while for questions. Although I don't even know if you guys have seen the questions page yet. So if you already have SnapRevise Chemistry, you'll upgrade automatically to the basic package when it comes out. No worries, Fatima. It's all about teaching that I just really want everybody to get it. Like, I know how stressful it is when you're sitting in a lesson and the teacher's just sitting there saying stuff at you. And you've got no idea what they're talking about. That happened to me so many times while I was at uni, and being too afraid to ask questions in a lesson is also really horrible. So it's nice, I think, the anonymity of being able to just type it in the comments is also cool, because you don't have to have like classmates around you that maybe not very nice about you asking questions, which is why we try to keep it so nice. in the comments. I want like it to be like the least judgy place ever, so that everybody feels comfortable with saying that they don't get it. That way I can help you get it. You don't have to miss me. You can, I will be here. I will still be here doing some free sessions. And I don't know. Yes, so you do need the ultimate package to get the web classes, but also we'll be doing a few for free as well. We'll keep them going with some of the free ones. They just won't all be free. Yes, you can upgrade. You should price discriminate this offer to year 13s. If you want to send in sort of like suggestions about things that I can't control, so like anything that's not the lessons, anything like pricing, if you want to send them in, go on our website. I think it's support@snaprevise.co.uk. You can send those things in to support, but I do not come up with the pricing. I have no control over that. Some is not enough. I'm sorry, Dan. I really can't. I can't do anything about that. I really can't. If Dan, if you want to hunt down like somebody that just wants to like pay for everybody ever, then like do that. But like just you know, I can't help that. And I don't have any more questions, so I'm gonna go and have dinner and like do the things that life requires. And I really hope that you guys have a good rest of your week and a good next week. So there are no web classes next week, but the week after there will still be web classes and they will still be free. So I will see you then, hopefully. Okay. Thank you guys for coming. I really appreciate you guys being here, and I'm sorry about all the lag that's been going on.